a 4.0 kilogram block that is at rest on a smooth horizontal surface. What is the velocity of the block at t equal to 5 seconds? Solution. Force is equals to 16 Newton. Mass m is equals to 4 kilogram. U, that is initial velocity u, is equals to 0 since it is at rest. T, which is the time, is equals to 5 seconds. Using the formula, F is equals to mass times acceleration, where A is the acceleration. Therefore, 16, which is the force, is equals to 4A. Therefore, A, making A the subject of the formula, you have 16 over 4, which will now give us our A to be 4 meters per second square. Using the first equation of motion, which is V equals to U plus 18. Therefore, V is now equal to 0 plus 4 times 5, which will give us 20 meters per second. Question 14. If a simple pendulum with a period of 2.0 seconds has its length doubled, what would be its new period? Solution. Period t of pendulum period is directly proportional to the square root of the length, or t is equals to k times square root of length. K, the constant, is equals to t over square root of length, which is equals to 2 over square root of length, or which is now equals to x over square root of 2l. X times square root of l is equals to 2 times square root of 2l. S is now equals to 2 times square root of 2 times square root of l all over square root of l. Square root of l cancel out, leaving us with s equals to 2 times square root of 2, which will give us 2.83 seconds. Question 15. A body of mass 5 kg initially at rest is acted upon by two mutually perpendicular forces, 12 Newton and 5 Newton, as shown in figure 1.53. If the particle moves in the direction OA, calculate the magnitude of the acceleration. Solution. Figure 1.54 example have formed a right angle triangle. According to the law of Pythagoras, the square root of the hypotenuse is equal to the sum of the square root of the other two sides. Therefore, the hypotenuse r squared is equal to 5 squared plus 12 squared. R squared is now equal to square root of 5 squared is 25 plus square root of 12 is 144. R, adding and making R the subject of the formula and crossing the square, we have the square of 169 will give us 13 Newton. From force is equals to mass m times acceleration a. Therefore, 13, which is the force, is equals to 5, which is the mass times acceleration. Making a the subject of the formula, we have that the acceleration is now equals to 13 over 5, which gives us 2.5 meters per second squared. Question 16. Velocity time graph, figure 155. The graph in figure 155 above describes the motion of a particle. What is the acceleration of the particle during the motion? Solution. A is equals to, in bracket, final velocity v minus initial velocity u all over t. The slope is now equals to, from the diagram, the slope is equals to v minus u over t, which is equals to a. But we are given that v from the diagram is the final velocity is 10 meters per second, and the initial velocity v is equal to 2 meters per second, and the t time, which is 2 seconds. Therefore, substituting the value a, it will now be equal to 10 minus 2 meters per second all over 2 seconds, which will give us 4 meters per second squared. Question 17. If a car starts from rest and moves with a uniform acceleration of 10 meters per second for 10 seconds, calculate the distance it covers in the last 1 second of its motion. Solution. From the second equation of motion, we have that distance s is equal to initial velocity plus half at squared. For 10 seconds, the distance s is equal to 0 plus half times 10 raised to power 2, which will give us 200 meters. Also, for 9 seconds, s is equal to initial velocity 0 plus half times acceleration due to gravity, which is 10 times 9 squared, which will give us 405 meters. Therefore, the distance covered for the last 1 second of its motion is 500 minus 405, which will give us 95 meters. Question 5. A block of mass 2 kg resting on a smooth horizontal plane is acted upon simultaneously by two forces, 10 Newton due north and 10 Newton due east. Calculate the magnitude of acceleration produced by the forces on the block. Solution. Since the force is magnitude is 10 Newton due north and 10 Newton due east, the resultant of the force will now make the force to have a resultant in a right angle triangle. Using the Pythagoras rule, we say that the square root of the hypotenuse is equal to the square root of the other sum of the other two sides. We have that r squared, which is the hypotenuse and the resultant, equal to the 10 newtons due east squared plus 10 newton due north squared, which will give us 200. Making r the subject of the formula, we cross the square root to the other side to become the square root of 200, which is the same thing to be square root of 2 times square root of 100, which will also equal to 10 times square root of 2 Newton. Using the force formula, which is force F equals to ma, we have already gotten the resultant force, which is 10 square root of 2 is equals to 2, that is the mass of the body times acceleration. Since we are looking for the magnitude of the acceleration, we now have make the acceleration the subject of the formula, which is a. We now have 10 square root of 2 divided by 2, which will give us 5 square root of 2, which is also the same thing as 7.07 meters per second. That means that the magnitude of the acceleration is now equal to 7.07 meters per second squared. Question 19. The resultant of two mutually perpendicular forces F1 and F2 is 13 Newton. If the magnitude of F1 is 5 Newton, what is the magnitude of F2?